So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 284, and in this video we are talking about the copy assignment operator, and I hope you already researched this a little bit, because we will not go too deep in this. We will just try to understand the basics, and this is just these two syntax here, and we try just to understand this example, and that's all what we need as a starter. And again, I linked you this article here, for example. This goes already a little bit more in advanced topics if you understand this very well. If not, no worry. Like I said, we need just to understand the very basics. And let's start here with the first syntax, and you can see we are using here a reference, class name reference, which means for later chaining the operator here, and you can see the operator, it's indicating we make an operator overloading, and here we are doing an assignment operator overloading. And important here is the parameter. Why so? Because the copy and swap item is using an argument passed by value, which means it is creating at this point a copy. So let's go here into the first example, which is this one here, and we start here with the main. You can see there are two objects created, A1 and A2 with the same type, and important is here we are doing not a copy. We are not calling here not the copy constructor here, because we are doing here an assignment. The copy constructor is only called when you create an object and initialize it, for example, with an already existing object. So don't confuse this one. And this is all time important to note, because if you have there are other implementations and wondering why it's not working. All right, with that said, we go here to the struct and see it has one integer variable, a string variable, defined default constructor, defined default copy constructor, which is defaulted, and here is our copy assignment operator, which we are overloading here, and it is the so-called copy and swap item, because we are not using here the reference, and we are doing here this kind of stuff in the body. So first of all, let's start here with this assignment. You can see the assignment later after we have two objects is very simple. You just use this little assignment operator, and then we can assign. Here a side note, again, why we are doing this. Normally you don't need that. In most classes which we till now created, we have never defined a default copy constructor. We have never defined a copy assignment operator, and the reason was because the normal assignment operator, which the compiler is creating, the compiler is creating a copy constructor, and the compiler is also creating this copy assignment operator by default, the implicit one. It is working, but, and now comes the reason why we are creating this one. But when we are allocating memory, then this assignment implementation, the default implementation, is not working correctly. And that's why we are doing this then on our own, and that is then the so-called deep copy. And deep copy means just in this body here, you specify how this assignment from one object to the other object should happen. You can then define it here by yourself. That's all the reason. If you understand this, that's enough for us. And now let's go here a little bit more again here in the syntax. It says here again, A1 reference in combination with return this is for chaining. What was method chaining again with operators? Let's go here. Here it's the same thing like here, what we have here, and here I added just one more object. And now here I assign A2 to A1, and here I do one more assignment. And this kind of stuff you can only do because we have this chaining effect here with this, where is that? Here, with this reference, and then return this one for chaining purposes. And very important, this chaining is all time starts from right to left, not from left to the right. So you chain first this one, and then you chain this one. All right? Okay. And then this was this part. Let's go to the next part. This is the indicator that we are overloading the assignment operator. This one is a parameter important here it is a parameter passed by value, which means the compiler will create here a copy, and the compiler will also call this copy constructor. So we need a copy constructor here already defined, which is working. And this one here is also used for already guard checks, because if the copy constructor already created without any problems, then this one here will work as well. And I don't go now in details because that's enough for us. And now we jump directly to the implementation, because we want to change now this assignment in our implementation. And you can see it is actually very easy. You just use this function here. It is called std swap. Now we understand what it means. It is a function defined in the namespace std, but we will not jump into this one because it's implemented when I show you this one with templates. We have not talked about templates, but in the end what this function is doing is just taking this argument and swapping out with this argument, and taking this argument and swapping out with this argument. Important, this is a swap. This one is not an assignment. So here we do an assignment. We take the right side and assign it to the left side. They become the same. Here they become not the same. They are just swapped out, which means this values become to this and this one this. So the question is now why we use here a swap. Let's go a little bit deeper here. So again, first we create here a copy of the other object. In our example would be the other object, this one here, the right side. This is that one. And then here you can see the swap function, that is the other object, other n, my a2. And this n is my left side, which is a2. So you are wondering perhaps, wait a minute, here's only just one parameter. Where is the other parameter? When you have something like this one and you use an operator overloading with just one parameter, in this case the left side is the caller and becomes the left side parameter, the implicit left side parameter. I think we have not talked about this, so don't wonder about this one. The left side, a1, is the caller and will be modified. That's why this whole thing becomes a1. a1 goes here to the assignment operator. Then a1 is calling here, you are passing here the other one, which is a2. a2 is now here. This one is a1. And then you can see it swap n here. This is from a1n with the other one. This is a2n. And then it is swapping as well the other one. This is just the string, the other one member wise. So that's very important that you understand this as well. And important here to see is this copied, the copied a2, because we create here a copy, is destroyed after this one here. Because we end the scope, this copy get destroyed, and the A1, which was the caller, this one we have already modified with this one here. You can see the A, I directly modify it, and this one needs guards normally. What I mean with guards is if there happens an error during this operation, then you need a guarantee that the state is not changed and all this kind of stuff. I skip here a little bit because this guard is already guaranteed when we have this copy constructor here. And the reason for that is this one. If this one works, then this one will work probably too. And this one, yeah, there are some more details with swap no exception. For example, if I click on this one, and then you can see there are different kind of implementations which we have to talk in the future, but not now. And then what it means, no exception, why it is safe, and all this kind of stuff. Like I said, that goes a little bit more to advanced topics now. For us, it's important that you just understand this works. It's very simple. You can use std swap, and that's it. You can see this, the syntax is very simple. You can just use that. This one we don't need. This is just a hint that it is called. This one we need a member-wise. That's also very important. You need here, when you use std swap, you need to make a member-wise swap, and not assignment swap. So you have here n you make a member-wise swap with the other. Then you have here an S. Then you need to make a member-wise swap with the other. Member-wise means all time you go through all these members separately. And why is this so important? For example, in this article, he said, in this section here, you can't use std swap. You have to create an std swap custom function. But in our example here, there is no custom swap function. And the reason for that is in our example here, if you use std swap and make a member-wise swap like so, which is shown here, then it works, which means you don't have to create a separate custom swap. But in his example here, for example, what he meant, or probably I'm not so sure, is this one here. Here it said that is his final, and you can see this final solution of the copy and swap item. It looks similar to this one, almost exactly like this one. The only difference is here, this swap. He is not doing this member-wise swap here. He is trying to call one swap a custom swap, which is, and that's very important, take the whole object, not member object, the whole object, and trying to assign it to the other whole object. You'll see, and that is not allowed. So if you try something like that, if you write here std swap here in this case, so you are not doing a member-wise swap of the separate object, this will cause indeed a recursion. Exactly that what he described here on top a little bit. He says that will cause a recursion, and the compiler will complain and crash and throw an exception, all this kind of stuff. But in our case, we are not doing this. We are doing a member-wise swap, and this works. And that's why, if you remember this little code, so what you have to remember when you create a copy assignment, just remember this line, and then remember you need every member separately here, swapping out, return this, and that was it. All right. So if you understand this, that's very good. I wanted to add here one more thing, which is in this example here, this custom swap here. If you create, for example, a custom swap like he showed here, of course you have then more options, and sometimes you need this more options, depends on the project you are making and all the things what you are using. This custom swap, where is it? This custom swap, what he has, which is here, which he defined here as a friend function, has the benefit that you can manipulate this swap a little bit more on your own needs, which means you can customize it a little bit more, because this one here is just using the standard swap method, which means you say, if this is working for me, I take it. And in this version of him, you can see you can define what you want here in this body. You can check for other things, you can make more guarantees and all this kind of stuff. That's why this one is also very nice normally, and for special projects, settings and all the requirements perhaps needed. But in our case, in general, if you have not any special settings, just take this one, very easy. You just make a source requirement when you allocate memory or files, make this one. It's very easy, straightforward, and very not complicated. And that's it for this video. In the next video we will talk a little bit about the other one. This is the second syntax here. And yeah, with that said, if you have any questions so far, write it in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.